Hello, everyone. Thank you so much for the opportunity to present still, and I apologize that I couldn't be there in person. For those that don't know me, this is what I look like. My name is Mischa Steiner. I'm the CEO of a company called Awesense, and I'm here to talk to you today about, well, I'm not there, but I'm going to talk to you about the road to the data-driven utility, and something that is really a passion of mine, and the whole area of data analytics and data science, and how the utility industry can really benefit from this transition that it's undergoing. Our company, Awesense, is really focused on optimizing humanity's largest machine, which is the electrical grid. It's an important mission for us, and I think an important mission for the world globally. And what we've seen is we've seen the electrical utility is changing. It's changing right now. If you look in the early 2000s, we were still solving problems with big capital expenditures. Then came the idea of having installations of smart meters, and this really was the first wave of data-driven systems, and using getting a device to generate more data, or having a device that generated more data. And then now the industry is transitioning into this data-driven methodologies that are using big data analytics and Internet of Things. Because the transition is happening right before our eyes, where we can see that renewable storage, distributed energy resources are becoming more and more prevalent in the grid, and this has all sorts of issues around grid resiliency and stability. And going forward, we will need tools like prescriptive, predictive analytics, and some machine learning as well, artificial intelligence, to really transition the grid into a form of grid automation or grid stability that will allow all of these different energy resources to interact with one another. So, as the grid becomes more complex, optimization becomes more and more important. Utilities need to use data to respond to this change, to make decisions, to make data-driven decisions around not only around business models, but also around how the grid is performing over time, and how they will manage the grid. So what we see in the industry is that by 2020 there will be over 750 million smart meters in place. But what we know is that smart meters alone cannot solve all the problems. And if you look at that figure, really, at over half of that is actually going to be deployed in China. China is going to be a huge market for smart meters. But what we do hear customers saying is that they spend a lot of money on their asset upgrades, and they don't know where that money goes, and their optimization is not any better, or that they need something beyond their smart meters to solve their problems. It's not the silver bullet that it was once expected or hoped to be, and there needs to be additional monitoring within the grid. We hear that they were able to get losses down. And that's something that Awesense is known for, is helping utilities reduce their losses, especially when they come to a point where they get stuck. The other thing we hear a lot is that data is really siloed in many different systems and many disparate systems, and the categories or applications themselves are also in silos, and unlocking that is a huge driver for a lot of our customers. Just answering the question alone of how do you make the data accessible to the entire business across its multiple functions has a tremendous amount of value for any business, including electric utilities. Some of you may not know that this is being tracked by the NRDC, that 75% of rate cases were rejected in the United States last year. And I know this is just one country globally, but this number has never been this high before. And really what we've seen is the electrical utility needs to justify its capital expenditures to regulators and utility commissions in order to make investments within their grid. But they often lack the data that is required or is being required or being deemed required by regulatory commissions, so that they can make these investments. And having more data-driven business models and business cases means that utilities can advance their grid in a way that they truly need to stay relevant and to really optimize their systems for many decades to come. So let's talk about why optimization is so hard to achieve. I think everyone realizes that generation and transmission have been well monitored for a long time, and we've had SCADA, in our substations for 30 or 40 years. Consumers are also becoming more monitored, with the rise of smart meters. So at the endpoints, smart meters allow us to monitor the C&I customers, commercial and industrial customers, and also households. But it's kind of a binary outcome. Either there are smart meters or there aren't, and either we have a lot of data coming from the edges or we don't. And for many utilities, the business case justification for smart metering alone is difficult for some utilities. But the fact is that the business case for additional monitoring in the grid is really difficult, and this is where 90% of all the issues and outages and failures and optimization actually lives, or the requirement for optimization actually lives, is in the distribution portion of the grid. So from the substation to the meter, this medium voltage network is poorly monitored and very under optimized. So we know now as an industry that pure analytics alone, relying simply on smart meters, are sort of blind to this portion of the grid. And what we really need to do is we need to advance the medium voltage grid, the distribution grid, to a state of grid intelligence, to a state of monitoring within the grid that can allow us to make data-driven decisions about how to optimize this portion of the grid. So imagine a world in which the in-grid data and data analytics are an enabler to data-driven decisions and overall grid optimization. The aspect of doing something like this, of really looking at your grid as a whole and looking at it as a holistic solution, means that you will be able to recover more losses, recover more optimization, both losses like technical losses, non-technical losses. You will be able to be more resilient against outages. You will be able to be more efficient overall as a business when you take action. And what we know is it takes about, for any substantially sized utility, it takes about 5 years for a utility to deploy and implement the entire smart metering infrastructure program and some type of big data analytics. And using in-grid data analytics and doing monitoring within the grid can yield a much higher result in the end, as opposed to simply just waiting for there to be a switch that's turned on for big data or smart metering analytics. And so what we encourage the industry and our customers to do is to actually get started, because the data that you have available to you as a utility actually has a tremendous amount of value in it today. So even if you don't have smart meters, you do have data that's accessible to you, and that data that you have can take you a fair ways along this maturity model. So this is the analytics maturity model, and just looking at this, there's a way to leverage the existing data that you have, and to make this transition, to create a very strong business case to transition the utility from a state of traditional business cases to real true grid intelligence and grid automation or distribution automation, through through process and capital automation, and using these techniques that we have available to us to really drive that grid intelligence future look in the system, through the regulatory and commission approval process. So right now we're basically at the best time to do this, because really there's a perfect storm. There's never been the ability before to have such easy access to big data analytics. Business transformation methodologies are there, and really the sensors and monitoring and intelligent devices are falling in cost quite dramatically. So the time to do this, to really transition to grid intelligence is right now, because there's other pressures that the utilities, as I mentioned, are facing, from distributed energy resources, and the way that Awesense has approached this as opposed to the conventional approach is really to use that data that's already existing within the system, and focus on the analytics efforts, and make decisions about where in the grid to solve the problems first, where in the grid would have the greatest impact, and using statistics and analytics and probabilities about how to actually monitor or how to optimize certain segments of the grid. If you look at the grid as a whole, it's very complex, but if you look at sub-segments of the grid, you can get quick wins out of the system to really optimize segments or sections of the system at a time, so that overall, over time, you're really optimizing the grid in a systematic and logical approach. This is where the business transformation and business process comes in, because it's not only just a transition to using new technologies, but it's also a transition for the business, is the business process needs to change as well. At the end of the day, we have physical assets as an industry. They are wires, they are transformers, and at the end of the day, a human being needs to actually act on that. And optimizing for that act or for that field work, or whatever the action is to take, whether it's a failed transformer or whether it's an actual asset upgrade, we need to make sure that that's the highest value or the greatest impact for the business. So, moving to a grid optimization or to grid intelligence, this framework is publicly available, but using data analytics and building risk models and segmenting the grid and segmenting the distribution grid into high-risk segments is sort of the first step. Selecting those high-risk segments and targeting that for further analysis is the second step. Integrating some type of case management or investigation tools so that you can drive the field teams into the necessary locations and basically collect and validate data as necessary. Then analyzing and reporting on those findings from the data within the grid, the metering data, the billing data, understanding and identifying, quantifying, and ultimately mitigating whatever that problem or loss is within the grid. And then using this data to learn, predict, and prescribe action over time. This is where really the advanced analytics and machine learning come in, and the next best actions. And I truly believe that machine learning will be an important aspect of distribution automation in the future. And one of my previous professors, and Dr. Andrew Ng from Stanford, he's been quoted saying that pretty much anything a normal person or human can do in less than a second, we can now automate with AI. And machine learning AI is really an impressive tool that can be used for all industries, including the electrical utility industry. As we move to more distributed computation and grid intelligence, this will be an important tool in the toolbox for the industry to really advance and automate and optimize the grid. I think we were lucky to be voted cool vendor by Gartner last year, at the end of last year, and part of what we're working on as a company is really to perform really intelligent grid optimization and really help our customers with the transition to grid intelligence. And it was a phenomenal award for us to be voted cool vendor by Gartner. For our customers, what's really important is tracking the metrics and tracking how they're performing with their SAIDI and SAIFI numbers, but also tracking, how much energy they've been able to save, what is the actual optimization numbers. We've been able to save our customers over 1 terawatt hour of energy, over 700,000 tons of carbon saved, and it's something that we're quite proud of as a company. It's like removing almost 150,000 cars off the road, and the equivalent of planting 18 million trees, and something the team is really quite proud of, and something that we track as a company because we believe it's important. But for the utilities in the room, what is important is to really think about how you can use data within your existing systems, or the data that's generated by your existing systems, to leverage that and really build something, build your business cases around data, and to partner with vendors, whether it's Awesense or it's someone else in the vendor ecosystem, or it's internally. Really look at data as your key golden nugget that can really help to optimize, your system and make those business cases really strong for the future. So I would just like to say thank you for everyone for listening to me speak, and I wish I was there to answer questions and to to really speak with you in person. But hopefully next year, or hopefully we'll be able to speak in person or speak on the phone at another time. Thank you so much.